In this videotape, we will study the circle. Before we get into the circle, I'd like to review some ideas from analytic geometry. You probably remember these, but I just want to go over them just in case. Let's say we have a line segment connecting 2 points, P1 with coordinates x1, y1, and P2 with coordinates x2, y2. I am interested in determining the midpoint of this line segment, okay, and also the distance between these 2 points, P1 and P2, or the length of the line segment. Okay, the midpoint of the line segment having the endpoints P1, x1, y1, and P2, x2, y2, is the point x, y, where x and y are given by the following formulas. The x coordinate of the midpoint is found by adding up the x coordinates of the endpoints, x1 plus x2, and dividing by 2. And y, the y coordinate of the midpoint, is found by adding up the y coordinates of the endpoints and dividing by 2. So right around here, it looks like we have the midpoint. We can denote that by M. That's the midpoint. It has coordinates x, y, where x is x1 plus x2 over 2, y is y1 plus y2 over 2. Those are the coordinates of the midpoint. I'm also interested in the distance between points P1 and P2. To determine that, we use the Pythagorean theorem. We can, through the point P1, we can draw a horizontal line. Let me redraw it over here for you for a second. Let's say we have here is the point P1, x1, y1, and here is the point P2, x2, y2. We want the length of that line segment, or the distance between these 2 points. Through P1, we can draw a horizontal line. And from P2, we can drop a perpendicular until it hits this horizontal line in order to finish off a right triangle. Let's say the right angle, okay, the vertex here is at the point Q. We can then determine the coordinates of point Q. Okay, since Q is on the same horizontal line as P1, it must have the same y coordinate as P1. So this is y1 for its y coordinate, so is this. Similarly, if Q is on the same vertical line as P2, it must have the same x coordinate as P2. It's x2 over, okay, y1 for the y coordinate. Now, what we've done is turn this distance that we're trying to find, okay, into the length of the hypotenuse of a right triangle, the length of whose legs we can figure out, because we know that if we have 2 points on the same horizontal line, okay, they have the same y coordinate, the distance between them is just the difference in their x coordinates, the absolute value of the difference in their x coordinates. So you can go, whereas you're going from x1 to x2, it's x2 minus x1. It's x2 minus x1 is the length of this line segment. Similarly here, if we have 2 points on the same vertical line, they have the same x coordinate, and the distance between them is the difference in their y coordinates, the absolute value, or simply the larger one, y2, minus the smaller one, y1. So, using the Pythagorean theorem, the length that we're trying to find, d, this is the hypotenuse, the length of the hypotenuse of the right triangle. The length of the hypotenuse of a right triangle, okay, can be found by saying the square of the hypotenuse is equal to the sum of the squares of the two legs. Okay, so d squared must be equal to x2 minus x1 squared plus y2 minus y1 squared. We have a right triangle. The length that we're looking for, the distance between P1 and P2, okay, that's the length of the hypotenuse. The square of the hypotenuse is equal to the sum of the squares of the two legs. And from this, by taking square roots of both sides, we get that the distance between these 2 points, P1 and P2, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we now know the midpoint formula and the distance formula. Let's go over them. We have two endpoints of a line segment. The coordinates of the midpoint are found by, well, the x-coordinate is found by adding up the x-coordinates of the endpoints, dividing by 2. The y-coordinate of the midpoint is found by adding up the y-coordinates of the endpoints, dividing by 2. Also, if you have the coordinates of the endpoints, one can find the distance between the 2 points, the length of the line segment, by using this formula. Let's try an example. Find the distance between the points A, having coordinates -3, 1, and B, having coordinates 5, 3. Find the distance between the points A and B. Also, I want you to find the midpoint of line segment AB. We can make a little picture so see what's going on here. 5, 3. That's point B, and point A is -3, 1. We want the length of this line segment, also the coordinates of the midpoint. -3, 1, 5, 3. Okay, somewhere around here. The length of the line segment, the distance between points A and B. Okay, it doesn't matter which one you call x1, y1, and which one you call x2, y2. If you say -3, 1 is going to represent x1, y1, and 5, 3 is going to represent x2, y2, then the distance between A and B is the square root of x2 minus x1 squared plus y2 minus y1 squared, the square root of x2 minus x1 squared, that's 5, minus a -3 squared plus 3 minus 1 squared, the square root of 5 minus a -3, that's 8 squared, plus 3 minus 1, that's 2 squared, the square root of 64 plus 4, the square root of 68, which can be simplified a little. 68 is 4 times 17. So it's the square root of 4 times the square root of 17, or 2 times the square root of 17 for the length of the line segment AB, the distance between the points A and B. We can also find the coordinates of the midpoint. They are found by adding up the coordinates of the endpoints and dividing by 2. So it's -3 plus 5 divided by 2, 1 plus 3 divided by 2. So we get, for this, -3 plus 5, that's 2 over 2, that's 1. 1 plus 3, 4 over 2, 2. 1 comma 2 for the coordinates of the midpoint of this line segment. Okay? Remember that in the distance formula we are subtracting the x coordinates and the y coordinates, whereas in the midpoint formula we are adding them up. Now with these preliminaries out of the way, we're ready to start our discussion of the circle. Most of us sort of know what a circle is. What we're interested in figuring out is an algebraic equation of the circle. Okay. Now you could say that the circle, set of all points in the plane that are a fixed distance away from a fixed point. The fixed point we call the center of the circle. And the fact that all points in the circle are a fixed distance away from the center, we call this fixed distance the radius. We want an algebraic equation of the circle. Okay, now let's say we have a circle. Let's put it on coordinate axes. We have a circle with center at a point A, comma B, radius r. We want to work out an equation of this circle. Well, equation of the circle is some sort of condition that has to be satisfied by a point if it's going to be on the circle. And here we could say a point x, comma y is on this circle if and only if its distance from the center is the radius. In other words, if it is closer to the center than the radius, the point would be someplace inside the circle, right? If its distance from the center is less than the radius, it'll be inside the circle. If its distance from the center is more than the radius, it'll be outside the circle. The only way it'll be on the circle is if its distance from the center is exactly equal to the radius. Okay, let's say we have a typical point x, comma y. We're saying its distance from the center must be equal to the radius. Okay? The distance of this point from the center would be the square root of x minus a squared plus y minus b squared. That's the distance between this point and the center using the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. Square root of x minus a squared plus y minus b squared. That is the distance between the point x, y, and the center. And the point is going to be on the circle if and only if this distance is equal to the radius, or r. If we now square both sides of this equation, we get x minus a squared plus y minus b squared equals r squared, which is a very common form for writing the equation of a circle. This is the center radius form of the equation of a circle. This is the equation of a circle that has center at AB and radius r. If you know the coordinates of the center and the radius of the circle, you can therefore get the equation of the circle. And the other way around, if you have the equation of the circle, you could then figure out the center and the radius from it. Example, find an equation of a circle with center at 5 minus 3 and radius 4. And this is the most direct kind of problem you can have. You are told the coordinates of the center. In other words, you're told A and B, and you are told what R is. This is the easiest one. You just write down immediately the equation of the circle is x minus a squared plus y minus b squared equals r squared. That is x minus the x coordinate of the center, x minus 5 squared, plus y minus the y coordinate of the center, y minus a minus 3 squared equals r squared or 4 squared, giving us x minus 5 squared plus y plus 3 squared equals 16. Here we have the equation of the circle, center at 5 minus 3, radius 4. By the way, in this form, this is called the center radius form. If you were to expand, okay, actually square this out and collect all terms on one side of the equation, we would have what we call the general form of the equation of a circle. Okay, so if you're given the center and the radius and there's no problem, you can get the equation of the circle. Sometimes you're not given the center and radius exactly, but you're given enough information to find the center and the radius. Consider the following example. Find an equation of the circle that has the line segment AB, where A has coordinates minus 3, 2, and B has coordinates 5, 8, as a diameter. Find an equation of the circle that has the line segment AB, where A has coordinates minus 3, 2, and B has coordinates 5, 8 as a diameter. I did not give you the center or the radius of the circle, but I gave you enough information to find both. Let's make a little picture, see what's going on here. Here's A minus 3, 2, and B is 5, 8. Okay, I'm saying that these are the endpoints of a diameter. This line segment is a diameter. Okay, from that, I can figure out that the center of the circle must be the midpoint of that diameter, and the circle itself must look something like this. You'll forgive the picture if it's not totally accurate. I gave you endpoints of a diameter. Minus 3, 2, and 5, 8. The center is going to be at the midpoint of this diameter. Okay? We can find the coordinates of the center using the midpoint formula. Once we have the coordinates at the center, we can get the distance between A and C, or the distance between B and C. They should be the same. After all, C is the midpoint of this line segment, and either one of them could be used as the radius. Let's go ahead and do that. The coordinates of point C are found by adding up the endpoints, the coordinates of the endpoints, and dividing by 2. Minus 3 plus 5 over 2, 2 plus 8 over 2. So C has coordinates minus 3 plus 5, that's 2 over 2, which is 1. 2 plus 8, 10 over 2, which is 5. So the coordinates now of the center we know. The center is 1, 5. Now, the radius is the distance between either minus 3, 2, and 1, 5, or 1, 5, and 5, 8. So let's arbitrarily say between C and B. So we're using the distance formula, using the square root of x2 minus x1 squared plus y2 minus y1 squared. x2 minus x1 squared plus y2 minus y1 squared. The square root of, let's say, 5 minus 1 squared plus 8 minus 5 squared. The square root of 5 minus 1, that's 4 squared, plus 3 squared, which is, either you recognize it right away as a 3, 4, 5 Pythagorean triple, or you say the square root of 16 plus 9, the square root of 25, or 5. Okay, so the radius here is equal to 5. We now know the center and the radius, so we're prepared to finish off the problem. The equation of a circle, if you know the center and the radius, x minus a squared plus y minus b squared equals r squared, where a, b, coordinates of the center, and r is the radius. So here we have x minus 1 squared plus y minus 5 squared is equal to 5 squared, or 25. Okay, we found the equation of a circle. Once again, we had to find the center and the radius first. We weren't given it, but enough information so that we could find it. The center was the midpoint of the diameter. The radius is distant from the center to either of the endpoints. And you should be able to work the other way as well. Suppose I asked you to sketch the graph of the curve x minus 4 squared plus y plus 2 squared equals 25. Sketch the graph of this equation. Okay, we recognize this as a circle. It can be matched to x minus a squared plus y minus b squared equals r squared. To do that, we would say this is x minus 4 squared plus y minus a minus 2 squared equals 5 squared. Instead of y plus 2, we write it y minus a minus 2, in which case we can then see that a is 4, b is minus 2, and r is 5. So the center, therefore, is at the point 4 minus 2, and the radius is 5. And once we know the center is at 4 minus 2 and the radius 5, it's very simple to sketch the graph of the equation, sketch the graph of the circle. I would go to the center, which is at 4 minus 2. I would go up 5 units, down 5 units, left 5 units, right 5 units to get a feeling for where the circle would be, and then try to sketch a circle through those 4 points. Okay, so this is 4 minus 2, so I'd go up 1, 2, 3, 4, 5. I'd go down 1, 2, 3, 4, 5. To the right, 1, 2, 3, 4, 5. From here, excuse me. Go to the right, 1, 2, 3, 4, 5. And to the left, 1, 2, 3, 4, 5. Okay, so from the center, go up 5, down 5, left 5, right 5, and then try to draw a circle through those points. Circle has center at 4 minus 2, radius 5. Okay, sometimes the problem is slightly more complicated because the circle is given to you not in the center radius form as it is here, but in the multiplied out expanded general form. Let's try an example like that. Sketch the graph of the equation x squared plus y squared plus 8x minus 10y minus 8 equals 0. When you have an equation in 2 variables, x and y, there's an x squared term and a y squared term, and the coefficient of x squared and y squared are the same as they are in this case. Okay, then we have and there is no xy term, no cross-multiply term with x and y. This must be the equation of a circle. Okay, so the question is, can we put it back into this form? Well, yes, we can if you remember how to complete the square, to go from this form into a center radius form. Okay, the way to handle this would be to collect the x terms together, the y terms together, and I would add 8 to both sides, get the constant over to the other side. X terms together, Y terms together, constant over to the other side. We recognize it as a circle. It has an X squared and a Y squared, and the coefficients of X squared and Y squared are the same. They're both, in this case, 1. Get the X terms together, the Y terms together, the constant over to the other side. Okay, now I'm going to use a version of completing the square, something that I find seems to work maybe a little bit better than straight completing the square here. I'm going to replace something like x squared plus 8x as a difference of two squares. It's very similar to the idea of completing the square. Let me show you some examples. If you have something like x squared plus 6x, I'm going to rewrite this as something squared minus something else. And here's how I'm going to do it. I'm going to take x, I'm going to take half of this number. Half of plus 6, that's plus 3, squared, and then subtract off this number squared. Square whatever is there and subtract it off. Okay, so from here I took half of this, half of plus 6 is plus 3, square it and subtract it off. Now we can check that this is really equal to this, because after all, what is x plus 3 squared? It's x plus 3 times x plus 3, which is by FOIL x squared plus 3x plus 3x plus 6x plus 9. So x plus 3 squared is x squared plus 6x plus 9. But it's not exactly x squared plus 6x. If we take 9 away from that, we'll have exactly x squared plus 6x. Okay, so I've rewritten this as this minus that. Let's try another example. Suppose we have x squared, well, let's say y squared minus 3y. Following the same procedure. Okay, the variable here is y. I take half of this number, the coefficient of the y here. Half of minus 3, we could write that as minus 3 halves. We square that, that's 9 quarters, and we subtract that off. When you actually multiply this out, you would get y squared minus 3y plus 9 quarters minus 9 quarters. That's y squared minus 3y. And what I want to do over here is replace each of these by something that it's equivalent to, but in this form. So for x squared plus 8x, write it as, okay, half of 8, half of plus 8, that's plus 4, square it and subtract off this number squared. This is equivalent to this. It's x squared plus 8x plus 16 minus 16. That's x squared plus 8x. Similarly, over here, I'm using the variable y. Half of minus 10, that's minus 5. Square it. Square minus 5, that's 25, and subtract it equals 8. I have replaced this by something it's equivalent to and this by something it's equivalent to, but it's in a much nicer form from our point of view. Because if you then add 16 to both sides of the equation and add 25 to both sides of the equation, you get x plus 4 squared plus y minus 5 squared is equal to 8 plus 16 plus 25. But 8 and 16, that's 24, and 25, that's 49 over there. X plus 4 squared plus y minus 5 squared is 49. We now have this in the center radius form, and we'll be able to sketch the graph of the circle without any difficulty. Let's go over here and do it. First, we have to pick off the center and the radius, so I will rewrite it as we have x plus 4 squared plus y minus 5 squared equals 49. I will rewrite this as x minus a minus 4 squared plus y minus 5 squared equals 7 squared. This is A, this is B, this is R. The center is minus 4, 5. The radius is 7 here. Remember, it's x minus the x coordinate of the center, so it's x minus A. A must be minus 4. Y minus B, so B must be 5. Some students just always like to remember that whatever the sign is here, it's the opposite sign when you're looking for the center, okay, as long as you understand where it's coming from. So from the plus 4, the center is at minus 4 plus 5. The radius is 7, square root of 49. Okay, and then once you have that, of course, sketching it is no big deal. Okay. Minus 4 minus 4, 5 is the center. We now go down 7 from here, up 7, here, to the right 7. We're already 4 over, so we just have to go, but at this level, and to the left 7. And then we try to draw a circle going through those points. Center at minus 4, 5, radius 7. Okay, I want to finish off with one other example on sketching a circle, or part of a circle. Look at this equation here. Sketch the graph, okay, of the equation y equals the square root of 16 minus x squared. Okay, first thing I want you to understand, when I say y equals the square root, I mean the positive square root. It's different. If somebody says to you y squared is equal to 49, you can say there are two roots to this equation. Y is equal to plus or minus the square root of 49. Y is equal to plus or minus 7. But if somebody just says the square root of something, that means the positive square root. It doesn't mean plus and minus. It means just the positive square root. Okay, now, in this form, you might not know what kind of a curve this is. But if you were to square both sides of the equation here, we would get y squared equals 16 minus x squared. You square both sides. Add x squared to both sides. And you say, gee, this is really x minus 0 squared plus y minus 0 squared is 4 squared. This is really a circle with center at the origin, 0, 0, radius 4. So let's make a picture of that. Center at the origin, radius 4. That's a picture of this. Now, how does that relate to what you were really asked to work on? You were asked to sketch that. This is y is the positive square root of 16 minus x squared. Geometrically, you get just the top half of this circle. In other words, here, it's the positive square root, therefore y can never be negative. If x equals 4, y is going to be 0. If x is equal to 0, y will be the square root of 16, y will be 4, but y will never be negative. Whereas if x is 0, you get y equals the square root of 16, meaning the positive square root of 16, you get just the 4. You don't get the 4 and the minus 4. So you square both sides to figure out what the curve is. It's a circle, center at the origin, radius 4, and then you say, well, gee, it was only the positive square root, so it's only the top half of this circle. And that's the picture. I've seen better, but that's the idea, the top half of the circle. If it had been y equals the negative square root, it would refer to only the bottom half of the circle. And that brings us to the end of this tape.